The universe is a strange place holding all kinds of mysteries within, and as much as we'd like to think, we've barely scratched the surface with our knowledge. For instance, did you know that we can see about 95% of the universe that we live in as humans? How exactly is that possible? In this video, we're looking at exactly how the edge of our galaxy defies the laws of physics and what that means for us. We live in one of the arms of a large spiral-shaped galaxy called the Milky Way. Our sun and all the planets that revolve around the star with their moons are all part of this galaxy. At night, all the stars you see in the sky are part of the Milky Way, and on lucky days, people can even witness the galaxy in its full glory as it appears to spread out all over the sky. But while all of that is pretty cool, the mystery that has plagued physicists all over the world lies at the very edge of our galaxy. To understand the crux of this mystery, let's go all the way back to the 1960s when an astronomer called Vera Rubin made one of the most important scientific discoveries of all time, leading to an entirely new way for people to understand physics and the world around us. Rubin started off by studying and observing the Andromeda galaxy, and according to her calculations, it appeared to be rotating in the wrong direction. All the stars right at the edge of the galaxy were moving at the same speed as the stars near the center. This meant that the stars lying on the edge were moving 10 times faster than they theoretically should have. Now, you might be wondering why that's a big deal, right? Well, that's because this directly violates Newton's laws of motion, and it's safe to say that this discovery took the whole world, or should we say the whole galaxy, by surprise. However, this is also what led to the discovery of dark matter, made up of invisible particles spread out all over the cosmos, colliding with each other. This dark matter makes up 84% of the universe and has an effect on how stars move within galaxies and how galaxies attract or repel one another. But then again, if we can't see dark matter, how are we sure that it really exists? That's where something called the LHC comes in. But before we talk about that, let's put things into perspective. For now, scientists acknowledge that they have a limited amount of information about dark matter, and that more experiments need to be conducted in order for us to understand what this component of the galaxy is really made out of and what it can really do. To do this, researchers have even tried to look for the dark matter within the Earth itself, digging deep into the planet's surface in hopes of coming across something. But of course, all of that has been to no end. But little do most people know that one of the biggest proofs of the existence of dark matter has been found in our very own galaxy. So, just like the Andromeda, the Milky Way also defies Newton's laws and spins much faster than it should, based on physical calculations. But if it didn't do that, our galaxy would simply cease to exist. Now, of course, this speed is all because of dark matter and its pull, as we discussed earlier. This is what leads us to believe that the galaxy is constantly affected by these invisible particles, and for them to work the way they do, they definitely have to occupy a huge part of the Milky Way. But that's not all, because the weird part is that while most galaxies are full of dark matter, some don't have it at all. But wait, shouldn't that prove the fact that dark matter isn't a thing? Well, not really. Consider this: when you take a look at all the energy and matter that our galaxy is made up of, physicists know that 26.8% of that is dark matter, and 68.3% of it is what you'd call dark energy, that is almost like a negative oppositional force of gravity. So, that leaves room for 4%, and that is the amount of normal matter consisting of protons, neutrons, neutrinos, and all of that. But if that really is the case, then why is dark matter so hard to find, since it's essentially making up most of the universe? Everything else in space is visible, if not to the naked eye, then to special kinds of telescopes, like in the case of black holes. But the very discovery of black holes is what holds so much promise. In fact, scientists believe that dark matter could very well be a consequence of black holes themselves. Primordial black holes might just be responsible for all the dark matter that exists in the universe at this point. How is that possible? Well, for those of you who don't know, primordial black holes are the ones that were created in the very first moments of the Big Bang, right when the universe was at its inception. These black holes range from tiny to supermassive and cover billions of miles in the universe. Now, black holes are points in space where matter is so tightly packed that they create their own gravity and even attracts light. Primordial black holes in general are relatively stable and not prone to the collision, which is why scientists believe that they can be good candidates for the origin of dark matter. Even Stephen Hawking suggested that in the first few seconds after the Big Bang, the density of the universe went through some fluctuations that could have created lumpy regions where the mass was more concentrated. These regions would then collapse into black holes, and research shows that the first ever stars and galaxies were actually formed around black holes when the universe was still in its developmental stages. So, it's very likely that a hidden population of these very black holes could be responsible for the presence of dark matter. Unlike every other discovery in the universe, dark matter is still largely theoretical, which makes all this so hard. But you'll be surprised to know that the LHC might be the most crucial part of this process. The LHC is the world's largest and most powerful particle accelerator that is located in a tunnel 100 meters underground at CERN, or the European Organization for Nuclear Research. The LHC stands for the Large Hadron Collider and is the device that was used to hunt down and discover the Higgs boson. Now, what the LHC does is that it makes protons collide with one another at extremely high energies. Now, when this happens, the protons give out a kind of subatomic debris. Through this process, the researchers at CERN are trying to create dark matter and then detect it. These experiments are also conducted using telescopes in space and on the ground, where researchers look for anything that might point to the presence of dark matter particles as they collide with one another in space. But how does that relate to the LHC? The kind of debris that the dark matter particles give out during their collisions and the proton collision debris observed through the LHC is expected to give some information about the nature of dark matter by contrast. And as soon as the researchers find out a similarity, they will be able to conduct the relevant tests to finally prove the existence of dark matter once and for all. Now, all of this is great, but then again, the question is whether the LHC is working on looking for signs of dark matter production in simple proton collisions. The answer is a little complicated, but to put things into perspective, according to what we know, the presence of dark matter particles is indicated by the absence of what you call transverse momentum. To calculate this, researchers combine the momentum of all particles that the LHC can detect to identify anything that might be missing from the equation. Mathematically, the total momentum of all these collisions should be zero. But in the case that it's not, that's when you know that the missing particle has actually been taken away by dark matter. Pretty cool, right? Considering all of this, it's pretty bizarre to think that at present, we can only see about 5% of what our universe is made up of. And if this 5% can be so complex, imagine the potential that the rest of it has. Do you think scientists will ever be able to prove the existence of dark matter? Let us know in the comments below. Thanks!